Let's see how copper sulfate undergoes electrolysis, and we'll also try to see that how the nature of electrodes plays a very important role in the formation of the products. So let's start by using inert electrodes. So we carry out the electrolysis of copper sulfate solution and we use platinum or graphite electrodes. Both are inert electrodes. That is, they do not participate in the reaction. So now we have copper sulfate. It dissociates to give the copper ions and the sulfate ions. Water dissociates to give H plus and OH minus. So there are two cations and two anions in the solution. So let's start with the cations first. So we have Cu2 plus and H plus. So let's look at the electrode reactions for the cations and the anions. So we have the two cations, that is Cu2 plus and H plus. We know that only one cation can be discharged at the cathode. So we look for the relative position in the electrochemical series. We see that the copper ion lies below hydrogen ions in the electrochemical series. So copper ions, they get discharged at the cathode. So copper ions are discharged at the cathode. So what is the reaction taking place at cathode? We have copper ions. Since they are getting discharged at cathode, they take two electrons and they form the neutral copper metal. The neutral copper is reddish brown in color and this is the product being formed at the cathode. Now let's look at the anions. We have two anions in the solution, that is sulfate and hydroxide. We know that only one particular anion can be discharged at the anode. So for that, we look for the relative positions in the electrochemical series. So we see that since hydroxide ions lie below the sulfate ions in the electrochemical series, so OH minus gets discharged at the anode. So now OH minus or hydroxide ions, they get discharged at the anode. So let's look at the reaction taking place at anode. So now OH minus, in order to become stable, it loses one electron, it forms OH. This OH species is not stable, so it reacts with another OH to form water molecule and an oxygen atom. Now again, the oxygen atom on its own is not stable, it combines with another oxygen atom to form oxygen gas. So the product being formed at the anode is oxygen gas. So now let's look at the electrolysis of copper sulfate solution. So in the beaker, we have taken copper sulfate solution, which is blue in color, and we take platinum or graphite electrodes, both of which are inert electrodes. So let's see how the electrolysis of copper sulfate takes place. So we see bubble formation taking place at one of the electrodes, which is the anode, as oxygen gas is being formed at the anode. And this reddish brown deposition on cathode shows that copper metal is discharged at the cathode, as we had seen from the electrode reactions. So these are the products formed as a result of electrolysis of copper sulfate solution using inert electrodes. Now let's carry out the electrolysis of copper sulfate using active electrodes. So this time we use copper electrodes. Copper in this case acts as an active electrode. It wants to take part in the reaction. That is, active electrodes always participate in the electrolytic reaction. Let's see how that happens. So this time we carry out the electrolysis of copper sulfate solution using copper electrodes. So let's see what happens. We are using copper anode and copper cathode. So they are separated by a small slit. We see that the bulb glows. This is because electrolysis is taking place. After some time, it is observed that the anode wears off and the cathode gets thickened. This can be seen from these markings and the extra projections. So what is happening in this? Let's try to find out. Again, when we have copper sulfate solution, we have 4 ions. The ions remain the same. The dissociation of copper sulfate gives us copper and sulfate ions. The dissociation of water gives us H plus and OH minus ions. So now, let's look at the electrode reactions at cathode and anode again. So we start with cathode. At cathode, we have copper ions and hydrogen ions. We know only one of them can be discharged at the cathode. So if we look at their positions in the electrochemical series, we see that the copper ions should be discharged at the cathode. So copper ions are discharged at the cathode, and the product being formed at cathode is the neutral copper atom or the neutral copper metal that is formed at the cathode. Now let's look at the reaction taking place at anode. We have 2 anions, sulfate and hydroxide. Again, we know that only one particular anion can be discharged at the anode. So out of these 2, we know that hydroxide ions should be discharged at the anode. But remember, this time we are using copper electrodes. And we know that copper is an active electrode. So it participates in the reaction. And how it does that is it does not allow hydroxide ion to be discharged at the anode. Instead, the reaction that takes place at anode is copper anode. That is the neutral copper. It enters the solution in the form of copper ions. So the copper anode that we are using, the neutral copper, it loses 2 electrons and the copper enters the electrolytic solution as Cu2+. So when we use active electrodes, that is copper electrodes in this case, the OH minus ions, which should have been discharged at the anode, they do not get discharged. Instead, copper, which acts as an active electrode, it enters the electrolytic solution in the form of Cu2+ ions. So what happens is, the anode wears off. This is because we had seen the reaction at anode. The copper continuously enters the electrolytic solution in the form of Cu2+. So as more and more copper atom from the copper anode, they enter the solution, the copper anode wears off. And this copper ion, which is now present in the electrolytic solution, they keep on depositing at the cathode. So we see that the copper cathode gets thickened. So why do we observe these changes during the electrolysis of copper sulfate using active electrodes? Because copper anode, it participates in the reaction. The copper atom continuously enters the solution in the form of copper ions. So copper anode wears off. And the copper cathode, because of the deposition of copper ions, it becomes thicker and thicker. So now, the copper electrodes during the electrolysis of aqueous copper sulfate solution, whether they act as active electrodes or inert electrodes. We have seen that when we use copper electrodes, during the electrolysis of aqueous copper sulfate solution, copper electrodes act as active electrodes. This is because the copper anode, it continuously participates in the reaction. The copper atoms from the copper anode, they continuously enter the electrolytic solution in the form of copper ions. And so the copper electrodes, they act as active electrodes during the electrolysis of aqueous copper sulfate solution. This process, that is the electrolysis of a solution using active electrodes, can be used as one of a very important application of electrolysis in the modern day. This very important application of electrolysis is for the electrolytic refining of metals. How is electrolysis used for the refining of metals? Let's see. So say we have to refine copper. We have to purify impure copper. So what do? We take thin strips of pure copper as cathode and we use impure copper that we have to purify as the anode. So now these are the two electrodes that we use. So observe what happens. We have the impure copper. So this rod or this anode is made up of impure copper that we have to purify. And as cathode, we use pure strip of copper. So what happens when electrolysis takes place? Since copper acts as active electrodes, the copper from this anode continuously enters the solution and it keeps on depositing on the copper cathode. So all the copper from this impure rod enters the solution and it is deposited at the cathode, and all the impurity which is present at the anode, it is settled at the bottom as sludge. So the sludge consists of all the impurities which are present. So by using this technique, that is, if we had to purify impure copper or if we had to refine impure copper, we make copper anode made from the impure copper sample that we have. That is made the anode, and pure copper is made cathode. As electrolysis takes place, copper acts as active electrodes. So copper atom continuously enters the electrolytic solution as copper ions, and all the impure copper is therefore converted into pure copper. So electrolysis can be used for the electrolytic refining of metals. So in this case, we saw that when we are using copper, impure copper, to purify it or refine it, what we observe is that the impure sample, the impure slabs of copper that we had used as the anode, it gets finished. This is because as the process of electrolysis takes place, all the impure copper present at the anode, it continuously enters the solution. So the impure slabs get finished and the pure copper rod, which was the cathode, it becomes thicker and thicker. So by using electrolysis, we can purify or refine metals. And this is one very important application of electrolysis in the present day, that is the electrolytic refining of metals. Electrolysis can be used to refine or purify impure metals.